Hi, video again on this time chapter 1.6, which is simultaneous equations. So we've got three different methods of solving for simultaneous equations. One method is the graphical method, and that's where we basically have an x and a y, so 2x plus 3y is equal to 6, and then we also have 2x minus y is equal to negative 10. And the blue line will represent the upper equation, and the green will be represented by this one. So here we have 2x plus 3y. Now you can graph these just using the basic system of the intercepts method. If I cross out this and solve for y, I can get the y value. So we find out that the intercepts here are 2 and 3, and we draw our blue line. Then the next one is 2x minus y. This is this green line here. If I cover x and I solve for y, I get a positive 10. If I cover this and solve for x, the other intercept would be at 5. And we notice when we draw, we're looking for the place of intersection. We found that point of intersection as negative 3, 4. All right, so that's one way to do it. Challenges with graphing, though, is if you don't have graph paper, you could be off a little bit, which means that you might not get the correct answer, or you could be in a different direction. So we just want to make sure that we use that if we have good graph paper and good clean values to use. All right, another way is the substitution method, and this is where we have the same. We use the same equation. 2x plus 3y is 6. 2x minus y is negative 10. We solve one equation for an easy variable. So in this case, I chose the negative y here because I don't have to divide. There's not going to be a fraction later or anything like that. This was the easiest one I could do. Subtract 2x from both sides. We get negative y is equal to negative 2x minus 10. Now I want to divide by negative 1 or multiply everything by negative 1. So we get y is equal to 2x plus 10. Now what I want to do is I want to substitute that into another equation. So we end up having here 2x plus 3. I substitute the findings from before. I just simply plug that in here. Equals 6. Distribute my 3. So I'm going to distribute that 3 across. We end up with 2x plus 6x plus 30 is equal to 6. Subtract 30 from each side, and you get 8x equals negative 24. And finally, after we divide by 8, we get x will equal negative 3. What do we do with the negative 3? Well, we've already solved for what y is over here. So now what we have to do is take this negative 3 and plug it back into this equation, and we find out what y is. So let's do it. Y is equal to 2 times negative 3 plus 10. 2 times negative 3 is negative 6 plus 10, so y is equal to 4. So again, our point of intersection was at negative 3, 4. Awesome. On a roll. So let's look at the final method. The final method is when we have, I'll move the cursor now because it's too much. Okay, that's good. So now we have final method of elimination, and that's where, again, same two equations I'm working with, not changing it. First step is you want to eliminate a variable x or y, whichever is easier. We just got to try and get rid of one of them. In this case, I'm going to multiply one of the equations by negative 1 to eliminate the x's. Now I could change y's. I could come up here and multiply this by negative 3 across and simplify, but then I start getting bigger numbers, and I don't really want to do bigger numbers. Remember math, if we keep the numbers simple, 2, 3s, and 4s, instead of 10s, 12s, and 30s, then it becomes easier for us. So we have 2x plus 3y equals 6. I multiply everything by a negative 1 to here. So this was 2x minus y equals negative 10. Well, now I've multiplied by negative 1, so we get negative 2x plus y equals positive 10. In this case, my x's will cancel, leaving me 3y plus a y is 4y. equals 6 plus 10 is 16. So we get 4y is equal to 16. And after dividing by 4 on each side, we get y is equal to 4. What do we do when we have that? Well, we simply plug it in the value and solve for the remaining variable. So we go back to one of the equations, doesn't matter which one, and we go 2x plus 3 times 4 is equal to 6. So here we have 2x plus 12 is equal to 6. I subtract 12 from both sides, and now we have 2x equals negative 6, and we get finally x is equal to negative 3, and lo and behold, once again, our point of intersection is at negative 3, 4. So 3 different methods, 3 ways. You can choose however you want. Some are easier than others, just depending on the system that you have, system of equations. All right? Hope you've enjoyed. Enjoy your day. Have a great one.